What should I say? Okay. Hello, everyone. So my first question is, does anybody not understand Russian here? Okay, I will continue in English anyway. Okay, so today I'm going to talk about functional virtual reality, about WebVR and Haskell. But first of all, if you want to follow the slides or the code that I will show you, you can find it all on GitHub at this link. Please take a minute to memorize it. FBY 2017 talk. And my nickname is Fizruk. Okay, so a little bit about me. I'm CTO and co-founder at GetShop TV in Moscow. We use Haskell for our backend, but we do not do any VR experiences. So this is just a side project for me. I also teach Haskell at Moscow State University for a bunch of students every spring semester. And I'm just a Haskell enthusiast for quite a while. So virtual reality. If you don't already know, virtual reality is the better reality. It is the reality that's made up, and you can go there and you can immerse yourself in this virtual reality. Usually these are 3D worlds where you can interact with objects somehow using various controllers. But mainly VR supposes that you use some sort of headset. So you close your eyes with this thing and you see only this 3D virtual reality. So when I first got interested with actually doing some things with VR, I didn't want to go to some cool gadgets like Oculus Rift or something like that. I did not want to invest a lot of money into trying things. And it turns out there's a lot going on in the browser. And there's this thing called WebVR, which provides some basic API to deal with VR from JavaScript. And you can check out the information on its site. And WebVR is supported in a few browsers, and it gets more and more recognition. And it's supported on multiple devices. So it looks like if you develop in WebVR, you're like cross-platform, or at least close to it. So, and to develop directly with WebVR is not very comfortable because it's low-level API. So there is this AFrame framework to build VR experiences, and it's wonderful for what you can find in JavaScript world. So AFrame relies on WebVR for VR part and on 3JS for the 3D part. And it uses declarative HTML to lay out scenes, VR scenes, lay out entities and components. It uses this entity component system architecture, which I will talk a little bit about later. And it's actually fairly simple to use. Like anyone can use it, can start building simple projects with it and playing around with it. And well, they claim that they are very performant, and they have some applications built with AFrame that perform relatively fast compared to native applications. So these are just some examples from their site. So AFrame uses declarative HTML. And the thing is that you just declare where things are in relation to each other. And it just works, and it renders, and you can interact with these objects. It's fairly simple. And you can, of course, go to the VR mode, and you can get your smartphone and Google Cardboard or something, and you can watch this simple thing and immerse yourself in this beautiful virtual reality. So, entity component system is very simple architecture principle. Basically, you have a bunch of components which are responsible for just, so each component tells you just something about some entity. For example, its physical properties, or its position, or its color, or its material, or something. So, and entities are just a collection of these things, of these components, nothing more. And systems is where all the logic is. So it's fairly simple. You just have a lot of these little things, and you smash them together, and you get your application. So, and AFrame also provides a nice thing, a visual inspector, which comes in handy when you are trying out where things should be and how they actually work. Okay, so it's all nice, and you can go home and try it, but AFrame has some problems. So first of all, the first thing that just didn't sit well with me is that AFrame is stringly typed. So everything that you put into your declarative HTML is stringly typed. You have vectors, you have colors, you have various structures. They are not checked at compile time because there is no compile time. And even if you get things wrong, you are not guaranteed to even have a runtime error. So you can just have some stuff not working, and you will not know why. So another problem is that you have to code your logic in JavaScript, and for me it's a problem. Probably for some of you it is a problem too. And another problem is if you want to compose things, if you want to make some subscenes or scene configurators, you cannot do this with HTML. So you have to resort to some sort of templating, or they have these mixins, and these are not very beautiful ways to do that. So the obvious solution to this problem is to use something I know is great at types and controlling these things. So the next question is, how do I go from Haskell to this AFrame JavaScript framework? So there's actually a JavaScript compiler for Haskell called GHC.js. So it takes Haskell code and generates JavaScript code. It has FFI support for JavaScript, so you can call JavaScript from Haskell. The nice thing about it is that it supports a lot of nice features of Haskell, like green threads and software transactional memory. And, well, you have pure functions. Also it relies on Node.js for builds and for template Haskell. It's just a minor detail. Okay, so and the nice thing, the extra nice thing is that you can couple the interpreter with the browser. So you can have a GHC.js session where you can run your Haskell code, and it will affect the browser DOM. Okay, so we have this, but we can't use just raw GHC.js. We want to use something more comfortable. So what front-end framework could we use to bind to this AFrame framework? So for me, there were two choices. First was Reflex. It's a powerful and mature framework based on ideas on functional reactive programming. And the second is Miso. It's a fairly new framework, but it is based on the Elm architecture. So if you're not familiar, Elm is very popular for front-end development lately. And it's been very popular because of its simple architecture, its simple principles. So Reflex relies on is a Haskell framework, and Haskell, as you might have heard, is a bit complicated. And on top of that, if you want to write Reflex applications, you have to also learn something called functional reactive programming. And I have to confess, I did not have enough time to invest into learning this thing. And some people have, and they say that it's very productive, but it just did not sit well with me, so I preferred a more simple approach. The Miso framework, which is based on the T. Okay, so like I said, it's based on T. It's arguably easier to learn because it does not require you to learn functional reactive programming, and it's also an isomorphic framework. That means that you can serve static pages without resorting to using JavaScript at all. However, that we don't need for virtual reality. Okay, so what's the idea of all this? So I want to take this user-friendly, let's say, Miso framework from Haskell, and I want to have AFrame, and I want to merge them together to have a nice Haskell experience for building virtual realities. So Miso, in this idea, Miso provides structure for application model and logic, and provides tools to construct those HTML scene layouts. And AFrame provides graphics, a VR environment, performance, some local component logic, and also AFrame has a lot of third-party components that we won't like to use, so it will provide that as well. Okay, so now I'm gonna show you how it actually looks like if. Okay, so here's a very simple application. So in this application, I have this function step 1, which is basically an application, a virtual reality application, which just has some layout and nothing else. It does not have any extra logic to it. So it has just an empty scene. A scene has a list of attributes and a list of child nodes. So I run the GHC.js-I, the interpreter, which is a little less trivial than you might think. And it starts a server at localhost at port 6401. So I go to the browser and I open this, I enter this localhost 6401, and then I have an HTML file that will talk to the GHC.js-I session and load code from it. So it just reloaded and it's empty, and I did not do anything yet. So I use this step 1, and I use reload AFrame app helper to reload an application in the browser. So I reload this application, and it starts, and now we see nothing. It worked. You can tell that it worked because we now have this VR goggles logo. Okay, so next step. So the next step would be to put something in our virtual world. And here we have a box, a red cube actually. So in AFrame, in HTML, you would have a box HTML node with a bunch of attributes. and you could not tell which attributes are the initialization attributes for the box, which attributes are actually components added to the box entity, and which attributes are just, I don't know, something else. And here you can see that we have default box attrs. It's an argument to the box combinator, and those are the initialization arguments. And you can tell exactly what they are because you have type system, and you have components as attributes in a separate list. So we have separated things. And you also can see that we have real typed values like vec3 for 3D vectors and not strings. So it's all nice, but how does it look? Okay, we reload AFrame app step 2, and we see the red cube. It's rotated, it's scaled, and it's red. Wonderful. Okay, so the next step. So the next step is actually, I find, the most interesting one. The next step is defining a foreign component. So there is a foreign component called environment that is located elsewhere, not in the basic AFrame components. And it has, among other things, two attributes. A preset is a name of a preset that creates the environment, and num dressing is how many objects to create, like to not make your browser work slow. Okay, so we define this in Haskell ourselves. We define a data type which encodes this initialization arguments. We make it an instance of 2JS val to transform it to something that we can generate for AFrame. And we simply define foreign component with its name and the type env. It's simple as that. And now, so this part is the foreign function interface for AFrame, basically. It's very simple. But now we can use this environment component in our scene and rely on these types that we have provided to prevent us from making mistakes. So here we have environment with preset forest and num dressing 500. So let's see how it looks. So it takes a few seconds to load, and it looks like this. Yeah, by the way, I can walk around, yes, and wander around and look around. So it's wonderful, right? And it's in Haskell, almost. Okay, so the next step is adding texture. So texture can be added just with a special attribute, and we can provide, because this is internet and browser, we can provide just a URL on the internet with some texture, and it will load, of course, if I have internet connection. Let's figure out if I have. Yes. Nice. Okay. So there's also assets management system, but I'm going to skip this. The next interesting thing is animation. So animation is created as a child node of an entity you want to animate. So we want to animate position. The starting value is going to be its current value, and the target value is going to be this thing. So it's going to go up a bit. And then we have some animation attributes, which are also typed, and you can look up what the type is and what arguments are there, and the type system will prevent you from doing the wrong thing and from typos and other things. So we want alternate animation, and we want it to last for 2 seconds, and we want it to repeat indefinitely. So let's see how that works. Okay, so it reloads and it now floats back and forth. Nice. Okay, so next thing. So if we actually want to build virtual reality experiences, we have to put interaction into our virtual world. And that we can do with this property, animation begin. For instance, so this is the simplest thing that we can do, right? We can animate thing upon some event, and we can use just the plain old DOM events like mouse enter, mouse leave, and click to animate differently our cube. So let's see how that works out. Okay. So if we now have a pointer. Yeah, I forgot to mention that. We now have a pointer in the middle of the screen. I'm not sure if you see it, maybe like that, right? So if I now point to the cube, it grows in size. If I leave the cube, it diminishes, and if I click on the cube, it starts rotating. So simple as that. So, and notice that everything that we've done so far is without any logic. It's just scene layout. So animation is part of the scene layout. So this little seemingly interactive and seemingly it seems like some logic is going on there, but it's local to the objects that we create, and it's encapsulated into the components we use. So layout is okay. So the next part is text. Text is added very simply with just a here with just a special text combinator. So I'll just show to you how it looks before we move to the last step. So it looks like this. So you have text in your virtual world. Okay, so and for the last step, we want to actually use Miso somehow, right? So far it was just a frame part bound to Haskell with types. Miso comes here to provide application logic and application actions. So we want to use this box as a button and to change the text below. So we want to have a model where we have a current text displayed and a list of available phrases, so to change to. And we have 2 actions, next phrase, switch to next phrase, and reset. So reset we will call when the app has loaded, and next phrase we will call when the box is pressed, is clicked. If you've done any Elm programming, this should be very familiar to you, like the model and the actions. Here we use a different combinator to start an application, and we have a few important things here. The initial action is the action that is started when the application has started. Mouse point, we just ignore that. Events, we ignore that. Subscriptions, we ignore that. The model we use is this. It's we use the text clicks the box, and we have these phrases to follow up. And here we have the update function. It's almost pure. So when we get the next phrase action, we just look if we have any phrases left. If not, then we reset to the initial model. If yes, then we just move to the next phrase. So it's pure code. So if you can see here is use the no F combinator that tells me that I cannot use any effects here. So it's just pure code. And it's the nice thing that I can use pure code for my logic here. And then I have view. So so far we've used the body of this function solely it, but now we use it with model. So we just replace here where we use text, we replace it with model text, and now we want to bind click on this object. Here we use Miso's onClick combinator that binds these boxes click event to the next phrase action that we get. And Miso handles the event propagation for us, and so that we only receive it in our pure function that handles actions. Does that make sense to you? Not too complicated? Maybe you want to see some virtual reality? Okay, let's see how it works out. So it works like this. I can still move around. I can click on the box, and you did it. Now click once again, and of course I will. And okay, why not? How much time do I get? Okay, so enough of fun. So this is just a short demonstration of the of the Miso AFrame library that I just put up, and basically you can take anything from AFrame and bring it to Haskell, wrap it into nice types, and use it to build virtual reality with Haskell. So as a proof of concept, this works, and this works nicely, as I think. So there are more AFrame components. There are a lot of them, actually. So environment is one of them, but there are tons of nice components that you can reuse. Okay, so this is all nice, but there are still a few problems. So one problem is that GHC.js lags behind GHC like by 2 versions. It's a lot. Because we develop regular Haskell applications with usually with the most recent compiler, and it's not very comfortable to use different versions of the compiler for different parts of your code. And another thing is that GHC.js interpreter is very, very experimental. I'm lucky that this sleeve demonstration worked, actually. I have encountered programs that crash in the interpreter, so I get like segfault. It's very unfortunate. So I would really like to use Haskell in the browser more, but this breaks my heart a bit. And another problem is that I would really like to create a cool component and share it with AFrame folks. But I cannot do this with Miso because Miso does not allow you to create local component logic. And actually, I think Elm and PureScript and any other functional programming thing, they have the similar problem. So I can do this, but I have to cheat. I have to do foreign function interface with JavaScript, and I have to write bits of code in JavaScript. And well, if I'm doing that, why not just do the whole thing in JavaScript, right? So, but I would really like to. So I can write a Haskell app and use Haskell components in Haskell app and use AFrame components in Haskell app. But I would like to use also Haskell components in JavaScript applications to share with the world. Right? But at this time, I cannot do that. So what's next? So there is some work to do on the library. a few problems I've mentioned. There is probably a higher level DSL possible for interaction with AFrame entity component systems architecture. And of course, I have to build something even more cool with Haskell than you've seen today. Yeah, I can't imagine what can be more cool. Okay, thank you for your attention. So here's all the information. Any questions? Are you stunned?
May I start? You said that after the description, the disadvantages of this, I wanted to learn from you. So why do you write that on this old, unstable piece of Haskell when it comes to pure script, for instance?
Okay, so my goal was solely to play with things. So I wanted to play with things. I wanted to play with Haskell. I wanted to see how GHTJS works out. I know about PureScript. I know about Elm. I know that they probably can be a bit nicer for this particular application. But another thing is also that we explore the uses of GHTJS at work. And we really want to share our logic code with the server side. We don't use VR there, obviously. But for some internal things, I would like to try to use GHTJS. And that's another reason why I was playing with GHTJS here. So to learn a bit more about GHTJS. For the what?
You mentioned that you need to add more DSL, high-level DSL, more types, etc. What are you?
Yeah. I did not cover the whole AFrame API in the library yet, and there's some documentation to work on. So, but the first usable version of Miso AFrame, like complete usable, is close enough, I'd guess. So the hardest part is probably to translate some tutorials from AFrame to Miso AFrame and to get more people involved, maybe, because I don't know how to do that. Maybe you want to participate? Some of you? No? Yeah. Yeah.
Do you see more ways to make your types like more interesting, like with applicatives or something like that?
Oh,
so
yeah.
Now we just records.
Oh, yeah, of course. This is the... so I've mentioned that there is probably a high-level DSL to work with AFrame. I think there is, yes. And what I've provided is just the basic layer. And there has to be a basic layer, and there has to be a higher level thing on top of that, I think. I'm not sure about applicatives and...
But by the way, this style of writing these records resembles monoid and applicative interface to the library opt-parse applicative. So I just remembered about it, like when you create these records, and there you do that by some applicatives. And with monoid, you just add different properties to your structure.
Yeah, and also you can add lenses too. So,
sure.
So applicative monads, lenses. Yeah, you can do that. I do not have a picture of how it would how it should look like to be comfortable for users. I know. So I tried to keep it simple.
For those who program in JavaScript.
For me, first of all, because I did not see an obvious way to use some abstract thing, and there are a lot of things going on, a lot of things that you can attach, and it did not seem like you can use some abstraction right away for that. So probably there is some nicer interface, but I'd have to think about it more and use this, build more virtual worlds to see what's needed actually, because my experience is bigger than yours. Okay, any more questions?